In this session, we will preview the application security domain. Application security refers to the controls that are included within and applied to system and application software. Application software includes agents, applets, operating systems, databases, and knowledge-based systems. These may be used in a distributed or centralized environment. Applications play a very important role in enforcing the security of the system through proper controls, edit checks, and audit trails. The security specialist must understand the application's development environment in order to provide input and guidance for including security controls into applications development projects. Software should be developed in a secure and controlled manner and have controls built in to support the security goals of the organization. Some software has been deliberately developed to break the security of information systems. We call such malicious software malware. For the security professional, malware is a very important area to study. Malware is not the only security risk in the software arena. Bugs, unseen vulnerabilities, and careless programming practices are the major means for attackers to achieve unauthorized access, system intrusions, breaches of security and integrity, network misuse, and other offenses. In addition, improper processing destroys integrity, and development errors often create problems for availability. Database applications, while a mature and established technology, have specialized requirements and security risks inherent in the volume of data being managed. Web applications also have specific risks due to the accessibility requirements. Web applications are also one of the major points of attack for penetration of information systems as a whole, since web servers are often connected on both sides of the firewall. As with all domains, I will provide this preview in the context of the three principles of security: confidentiality, integrity, and availability, more commonly referred to as CIA. From a confidentiality perspective, applications must ensure that access is only given to authorized people and processes. The program or application must also ensure that each user only gets access according to their privilege level. The application should limit the use of the application and data to the intended purposes and prevent covert channels and object reuse. Application security primarily addresses the integrity part of the triad in an effort to maintain the accuracy of data. Applications can often prevent the corruption of data through proper edit checks and controls. The application must also be written to ensure the correct and complete processing of transactions. Malware may specifically target the integrity of the data. Application security addresses the availability of the system by protecting against malware that may waste system and network resources. The whole purpose of the application is to make it easy for users to access data correctly. The application must be written in such a way as to provide the information properly. Even when an application is used as intended, if the application is not optimized for the number of users, it may fail. Our preview of application security will focus on three main areas. 1. Programming concepts. 2. Threats and malware. And 3. Database concepts. Section 1. Programming concepts. Programming languages were developed over the years and improved in both ease of use and increased functionality. This has made programming of an application much simpler, but has also increased the risk due to non-professional programmers developing applications without security controls or following proper programming practices. All organizations have to ensure that they have proper backups of all software, as well as documentation of the function of the software. The choice of programming language can have implications for security. Categorization of programming languages can be done many ways. For example, compiled versus interpreted. Compiled languages are written in a somewhat human-readable script called source code, which is then translated to machine language, or machine code. It may be argued that almost any language can be compiled. Interpreted languages are distributed and stored in a clear, readable script and can be altered before execution. Interpreted languages can be a serious security risk in most environments. Compilers translate high-level source language into machine language, where interpreters translate source language statement by statement at execution time. Object-oriented programming, or OOP, replaces classical programming techniques. OOP promotes code reuse. Code reuse reduces development time and thus reduces programming costs. C++ is an example of an OOP language. It combines the traditional C programming language with object capabilities. When building traditional programs, the programmers must write every line of code from scratch. With OOP, programmers can reuse pre-written blocks of code or objects. The advantage of OOP is that an object can be used repeatedly in different applications and by different programmers. Various aspects of OOP can assist with security. For example, data and functions can be hidden from the outside world. However, functions may also be hidden from the developers, so care must be used when relying on security protection in OOP. Objects are encapsulated with OOP, possibly providing some security. Objects have methods, which are code with interfaces, and attributes, which is data, encapsulated together. There are three main components of OOP. 1. Classes. These are templates for objects. 2. Objects. These are instances of classes. And 3. Messages. Objects request services by sending messages to one another. Security professionals should be familiar with some of the seemingly obscure application terms that have an effect on security. 1. Inheritance. This is when an object that is called by another object or program derives its data and functionality from the calling object. 2. Polymorphism. Different objects may respond to the same command in different ways. An object that is derived from a class for which security has been defined may inherit its security characteristics and functions. However, due to polymorphism, the functions may not be fully secure in the new object. And 3. Polyinstantiation. Polyinstantiation is not only fun to say, but translates to many instances. Polyinstantiation is to create a new version of an object by changing attributes. This may be used in support of security by removing data, or may be a risk due to the removal of security features. It is also the technique used to prevent inference violations. Essentially, it allows different versions of the same information to exist at different classification levels. Therefore, users at a lower classification level are not aware of data that exist at a higher classification level. Distributed programming requires abstract communication between hosts. Distributed computing entails programs located on different computers cooperating in the same application. Applications are divided into components. Each can operate in a different location or platform. Two of the major protocols in use today are CORBA and DCOM. Common Object Request Broker Architecture, or CORBA, is platform neutral and an open standard. CORBA allows applications to communicate with one another regardless of where they are stored. It is based upon the Object Request Broker, or ORB, concept. The Object Request Broker, or ORB, establishes a client-server relationship between objects. Using an ORB, a client can transparently locate and activate a method on the server object either on the same machine or across the network. CORBA and ORB techniques are examples of the reference monitor concept discussed in the security architecture domain applied to distributed systems. Distributed Component Object Model, or DCOM, is a Microsoft-only protocol that provides similar functionality to ORBs. It is also enabled by default on all versions of Windows. From a security perspective, DCOM can be exploited and used by worms to spread. Section 2. Threats and Malware. Now that we have covered the basic concepts of application security, let's look at the threats to our applications, including malware. Here's a list of some of the threats to guard against. 1. Buffer overflows. A buffer overflow is a weakness of both poor coding practices and programming languages, typically C or C++. The buffer overflow is one of the oldest and most common program vulnerabilities, having existed almost since interactive computing began. Buffers are the memory containers for programs executed by computers. Programs in execution define the buffers they will use. The amount of data that is sent by the program to the buffer is unknown until the time of execution. Overflow is the process of putting more than expected into a container, or buffer, which spills into some other place. When data overflows one buffer, it flows into another buffer or another program. When an input is more than expected, the program should reject the data gracefully. When the program does not reject the data gracefully, a buffer overflow occurs. Technically, to stop buffer overflows, you must check all bounds on array and pointer references for all executing code. Administratively, bounds checking is an easy task for one programmer on one system, but to know how many other programs are running is difficult. 2. Denial of service, or DOS. DOS is the result of another person or process consuming the resources on the system and thus limiting the resources for the use of others. It is an attack against availability. DOS generally does not involve erasure or destruction of data or resources. A DOS does not need to be complex. For example, invalid searches on a website can cause a denial of service. 3. Race conditions. A race condition results in the false assumption about the current state of a program or a variable in a program, which in turn results in the loss of integrity. When two or more processes use the same resource, each process can falsely depend on the state of that resource being constant, but each process can affect the resource. For example, the glass is full of water and under an opaque box. Whoever gets thirsty first drinks. The other assumes the glass to be full and reaches for an empty glass. Kind of odd, huh? Well, that's a race condition. A particular type of race condition for file access is a time of check versus time of use, or TOC-TUI. TOC-TUI issues occur when control information is changed between the time that the system security functions check the contents of variables and when the variables are actually used. And 4. Code injection. Malformed input, more generally known in security literature as malformed data, involves various means of getting illicit commands or packets through defensive measures. An attack using malformed input frequently involves commands or code that are somehow crafted to appear to be merely data, hence the name malformed data. These attacks are particularly prevalent in web applications. Developers may use a shortcut in creating web pages by embedding SQL statements into an actual web link in order to have the commands passed to the supporting application. Attackers can view this source code, find such embedded commands, and modify them in an attempt to see what effect the modifications have on the application. SQL and Unicode are by no means the only forms of data that can be used in this way. The buffer overflow attack can be seen as a special case of malformed data. SQL injection is inserting a series of SQL statements into a query by manipulating data input into an application. A virus is defined by its ability to reproduce and spread. A virus is not just anything that goes wrong with a computer, and a virus is not simply another name for malware. Trojan horse programs and logic bombs do not reproduce themselves. A virus usually requires some action from the user in order to trigger the infection. This may include launching an executable, opening an attachment, or installing a program. A worm, which is sometimes seen as a specialized type of virus, is distinguished from a virus since a virus requires an action on the part of a user to trigger or aid reproduction and spread. The action on the part of the user is generally a common function, and the user does not realize the danger of the action or the fact that he or she is assisting the virus. The only requirement for a program to be defined as a virus is that it reproduces. There is no requirement that the virus carries a payload, although many do. In many cases, the payload is limited to some kind of message. A deliberately damaging payload, such as erasure of the disk or system files, usually restricts the ability of the virus to spread, since the virus uses the resources of the host system. In some cases, a virus may carry a logic bomb or time bomb, which triggers a damaging payload at some date or under some delayed condition. A file infector virus infects program files. A boot sector infector virus infects the master boot record, system boot record, or blocks on the physical disk. It usually copies the existing boot sector to another unused sector. A macro virus is created using the macro programming of an application, such as a word processor. It infects data files and tends to remain resident by infecting a configuration template. An email virus specifically uses the email system to spread. Email viruses are aware of the email system functions. Most email viruses are technically considered worms. Section 3. Database Concepts. Databases are the oldest form of business computing and still form a major field of information processes as a whole. Confidentiality of certain types of data and the ready availability of certain databases are frequent concerns, but in the normal course of events, integrity of the data is probably of greatest concern to those involved with database management and administration. Originally, data-oriented programs would contain their own data, hard-coded into the program. The separation and independence of data being made available to a number of applications that might need it was actually a major step forward. Despite the popularity and use of many other computer applications, database systems remain the major business application. The goals of databases are to reduce duplication of data, thus reducing need for more storage. Inconsistencies, such as multiple spellings or multiple terminology, can help clarify management's policy. Typically, a database management system, or DBMS, has four major elements: the database, hardware, software, and users. The database element is one or more large structured sets of persistent data. Databases are usually associated with the database engine, which is the software that updates and manages the data. Special application software provides the interface with the users, who provide the data queries, reports, and entry. The structure, format, and contents of the various databases around the enterprise should be accessible from a central location. The data dictionary is a useful tool for managing the spread of information sources around the company, which may otherwise lead to the problem of duplicate and contradictory data. The three major database models are hierarchical, network, and relational. The hierarchical model is the oldest of the database models and is derived from the information management systems of the 1950s and 1960s. This model stores records in a single table. It uses a parent-child relationship where the child only has one parent. It is limited to a single tree and difficult to link branches. The reason for the limitation on linking was due to the fact that data was often stored in sequential devices such as tape, and searching for an additional link might mean rereading the entire file. Even today, there are hierarchical legacy systems that are still being operated by banks, insurance companies, government agencies, and hospitals. A directory tree is an example of a hierarchical system. The accessing of the data in a hierarchical system requires mapping out the route to the data piece by piece through each layer of the data rather than directly via joins and indices as used in the relational model. The network data model was introduced in 1971. It is an extended form of the hierarchical data structure. It does not refer to the fact that the database is stored on the network, but rather to the method of how data is linked to other data. The network model represents its data in the form of a network of records and sets that are related to each other, forming a network of links. The relational database is so frequently used that many people think it is the only database model. In addition, because of the tabular form of representation used to describe relational databases, some people believe that any structured flat file is a relational database. In fact, proper relational databases have a formal definition which assists with the provision of integrity of the data. Part of the formal definitions used in relational databases comes from the Clark-Wilson integrity model discussed in the security architecture domain. The relationships between the data elements provides the framework for organizing the data. This concludes the preview of the application security domain of the ISC² CISSP CBK.